we think about it in a microcosmic way, and that is dust, which, accumulates from time to time, and we just wipe it off the counters and things. But apparently dust has a secret life. This is a book called The Secret Life of Dust by Hannah Holmes, and it's published by Wiley. It's a science book. It's a thrilling book, and you know how I am with criticizing books. This book is mostly a compendium of facts, which are really stunning. She's done quite a lot of work. In fact, there may be an acknowledgement in this book of Professor John Merrill, who talked with Hannah Holmes when she was writing this book. I'm going to get you a copy of this, and I'll get you a copy if you'd like.
Sure.
It's just It's called The Secret Life of Dust. The Secret Life of Dust by Hannah Holmes. It's really a super book.
And it isn't about housework, Ray, right?
No.
Okay.
And in case you're wondering, I can no longer hide the fact that I am half raccoon American.
It took a fall. Last night, was it, Ray?
I'd like to say that it was.
I had nothing to do with it, Ray.
No,
He's innocent.
It was a jealous boyfriend at the high school level. Actually, I fell down, and so I have a shiner, and that's.
Thank God you didn't break any bones. Praise the Lord.
Amen. Yeah. Well, I've got may I ask a couple of basic questions about weather? I've been thinking that there's a subject which we look at every day, and we're concerned, everybody is concerned about different things, different parameters. We want to know if we need to wear a T-shirt or a shirt with long sleeves. We want to dress appropriately. Rhode Island is, you mentioned the other day on TV that we had a 23-degree difference in Rhode Island the other day, didn't we?
Indeed.
Wasn't that something?
From the sea breeze on the coast to warmer temperatures inland. And that's very common in the spring. And as a forecaster, it's ingrained in a meteorologist who forecasts day in and day out to sort of like try to do a 3 or a 5-degree temperature range. And so, it's the kind of thing now where we've got to show a map up there and try to account for that difference in temperature. In fact, I even saw a one-day greater this spring. It was 81 in northwest Rhode Island and 47 on the coast. So there's 34 degrees. That's like a degree a mile, right, if you take it that way inland. So it's a fascinating business, and this time of the year, it's a tough business to forecast and get those numbers exactly right.
Is the 5-day a hard thing as opposed to a 3-day?
It depends. It used to be an old school of thought that you lose 10% in forecast accuracy as you go out day by day. Maybe it's 85% for the next day, and then 75, 65, and so on. A 5-day forecast really depends upon the atmosphere on a grander scale across the whole hemisphere, or North America, if you will, and are there any changes taking place in the steering winds? Because you get these patterns that set up. And sometimes the patterns are very stable. They don't change very much. And with that in mind, then you can look out 5 days and have a good idea that, what the weather's going to be. This week has been particularly difficult because we have what's called a blocking high pressure up over Canada. And in fact, around Hudson's Bay, southeastern Canada, in that whole general area. And it has been difficult for me to decide whether that high is going to tilt a little this way, tilt a little this way, and then we have a low pressure high in the sky that's trying to go under it. And where is the cloud line going to come up to from the low, and the rain going to come up to from the low and stop? And in fact, I said, this is Thursday night, I said on the air that it's going to rain in New York, and it's going to rain in Bridgeport, and maybe a few showers in New Haven, And Groton and London, maybe some sprinkles, and Block Island, so it's going to be that kind of thing. So when you have that kind of situation, it's a little more difficult in the 5-day. And also, it can be difficult in the 5-day when weather systems are moving fast, because then it's a timing thing. If you go out 72 hours and you're off by 5 miles an hour, you're off 350 miles, and whatever you think is going to be in Rhode Island may be in western Pennsylvania.
So a little thing can add up.
That old butterfly theory, right? Little butterfly flaps its wings, and then, that whole thing changes the weather pattern, that kind of thing.
Is that true? There's a saying out there that if a butterfly flaps his wings an extra time somewhere in the rainforest of the Amazon, that it could result in a weather system on the other side of the world. Is that?
Well,
I didn't mean to set you up.
Well, I think it's really the issue of are these systems a set of feedback loops? And the answer is unequivocally yes. So that one flap of the butterfly wing may or may not have an influence, but it's going to have effects on the system of which it's part of it. And so part of it is just the connectedness of all of these elements is key. And when we talk about, the small things build up, you're talking about dust. The small little bits of dust that landed 100,000 years ago is what we're relying on to feed ourselves, because that's what the good soils of the Midwest, the lush soils of the Midwestern United States, are all that accumulated dust in a long time past glacier. Just accumulated a little rate, and that's the rich soils that they found when they moved west, and that they basically are mining, because unfortunately much of it's also going down the Mississippi, and that dust is now in the Gulf of Mexico.
Or blowing away when there's
Right.
spring windstorm.
That's right, after you plow in the spring windstorm. And if you've ever experienced it, it's incredible. I've only been in one really bad one in the Midwest, but the sky turns red, and you could tell where it came from based on the geology. In this case, you could say, it's coming out of Oklahoma. You went out, it's like you're getting sandblasted. Now, that's not comparable to the ones that we had in the 30s, but the process is the same and continues to this day. We're moving dust around all over the earth, and it's having impact. We had actually one situation where I did feel it like it was in the 30s, and that was in the Gobi Desert 2 summers ago, where I was doing some work, and I'd never experienced anything as intense. That the dust storms, everything just all of a sudden, the wind picked up these dust, because these are very dry. There's lots of unconsolidated soils, and you just basically, it's as if it's raining soil. It's just everything. It's just as thick as
The
can be.
soldiers were saying that they
Yeah, I was
couldn't
thinking
keep their
about
eyes
that.
open.
Yeah.
It
Oh,
hurt
yeah.
their eyes.
Well, yeah.
No, you couldn't go out. And what was amazing in this case was we were supposed to fly to Ulaanbaatar, the capital of Mongolia.
Oh.
And we were trying to decide, should we go? And we're looking around saying, my God, are we going to fly in this stuff? And we thought, well, the Mongolians know. They flew in it, and we got there safely. And, the planes were equipped to deal with it. But I'll tell you, it was a little scary. It was a little knuckle kind of
year was it?
This was in July. End of July.
It's even worse in the springtime, as you
Right.
know.
Right.
There are times when they don't fly.
Right. Oh, I'm sure there are events even more severe when they fly, but around here it would have shut us down.
Gary mentioned the steering wind. Are there roads in the sky? This is a globe, which is actually a science satellite photograph. I don't know if you can see this, but as we look at the globe there, are there roadways like there are currents in the sea? Are there roadways in the sky carrying? Well, Hannah mentions things like 100. A million boxcars. 1 million boxcars a year flying up from the deserts on their way to our Pacific and our West Coast. I was talking with John yesterday. We talked about something coming to the East Coast, didn't we?
Yeah, in 2001, for example, there was a spring dust storm in China. These happen every year, but April of 2001 was particularly dusty. And I happened to be on a field experiment observing dust and smoke and haze flowing out of Asia. We were on a marine base in Japan. We were using instrumented aircraft. We had ships. We had cooperative investigators from Korea and Japan and China and other countries, Taiwan, Chinese Taipei. We had various means by which we were detecting all of these materials, trying to quantify, trying to find out how much material there was, what its chemical composition was, what its effects were. We anticipated there would be dust storms. We planned for it. And sure enough, in the beginning of April, there was a spectacular dust storm. We were able to sample it. This turned out to be a very large storm that resulted in very, very large amounts of dust flowing out of Asia, first towards the northeast over the northeast out of China over the Pacific Ocean.
So from Inner Mongolia.
From Inner Mongolia. And then later in that same week, a second system came out, and the largest amounts of dust came a little bit further south over Japan. We were able to sample that. We were in southern Japan. So we were able to sample that dust. But both of those masses of dust then continued out across the Pacific, following the storm track that is normally present.
Where were you sampling? Surface or flying? Flight.
With the aircraft, we were flying from the surface up to about 6 kilometers in the atmosphere.
10 miles or so.
10 miles or so.
I'm sorry, 4 miles.
4 miles. We both did it backwards. Anyway, we also had sampling on the surface from a vessel, from a NOAA ship. We had surface sampling stations at various sites.
And what do you have, like little things that grab the dust, and then you look at it under a microscope?
They had a marvelous collection of instruments, most of which were instrumental, so they would allow the dust to pass into the aircraft and then pass through the sampling volume of an instrument, so they would watch it and shine laser light on it, scatter light from it. They would,
Fascinating.
in some cases, they would collect dust on filters or in other collectors and then analyze it afterwards. But let's stay with the storm for a moment.
Yep.
And maybe we'll get back to this other stuff. This dust flowed out, followed a couple of paths across the eastern parts of Asia, and then across the Pacific, continued all the way across the Pacific Ocean, and got close enough to the surface over North America that it was detected as an air pollution event. There were air pollution alerts in several places. There was visible haze in the sky that was caused by this dust from China, all the way across the country. In fact, there were observations being taken for another purpose in the Atlantic, and they detected measurable amounts of this dust in the Azores. So the dust
Got across the Atlantic.
goes all the way across the Pacific, which is the widest ocean, all the way across North America, and then
Oh, that's
most of the way across.
amazing.
It is.
Dust travels.
It's amazing.
Are there roads in the sky?
Well, the storm tracks are the closest thing that I would describe as like a road, but they're variable in the strength of the wind, and they don't flow straight west to east. They wiggle, and the wiggles correspond to the disturbances and result in the surface disturbances, the storms that we experience. And when Gary was talking about things changing rapidly, there's two aspects of that. One, the wind speeds can increase and the storms can move by quickly. Also, sometimes the wiggles get larger and larger and more intense storms form more frequently. And so if there are, I would say it's, rather than saying it's roads, it's like possible tracks in an open area. There's several different ways you can go, but generally the winds are going to blow from west to east, but the tracks vary.
We think about this in terms of air pollution. You mentioned air pollution. So we think about these things in terms of a macrocosmic, a giant event, which is probably going to be harmful to our health. But it seems that this 100 million boxcars of dust has a lot to do with our rainfall.
Sure.
And even the accumulation of clay at the bottom of the ocean. Steve, were you talking about that the other day?
Well, and also just about I talked about the soil formation and the movement of materials, and it's key. And the sort of inverse also, though, is you put more particles in the atmosphere and it changes the climate. So
changes the climate.
Changes the climate. Yeah. So that one of the key factors in actually offsetting climate change and the increased amount of carbon in the atmosphere is actually these aerosol particles. And so as we pollute more, in terms of particularly sulfur, but also the particles, the dust particles, it actually cools to some degree. And it's offsetting, but it's not nearly offsetting enough. I mean, the climate is getting warmer globally and in this region, and in Rhode Island in particular, we have a clear record of a warming climate.
Does it cool because we keep the sunlight from entering us? Is that why
Yeah,
it's
basically
cooler?
it creates a reflective surface, so some of that energy coming in is bounced back
Is this
out to
what
the
we mean
atmosphere.
by when people talk about global cooling? Is this an example of global cooling? Some people also talk about global warming.
Well, we're undergoing global warming. We're not undergoing global cooling. There are multiple components to the climate change. So one of them is understanding how differential clouds, so how as clouds shift as a function of different moisture regimes, how these aerosols, the sulfur in particular we put up as far as pollution, how does that work? Both of those are cooling components, but the warming associated with increased CO2 and other greenhouse gases is much larger than that cooling. And it's the aggregate balance, and of course it happens over space. So it's not one big globe, but different areas that react differently. So you have hot spots of cooling and hot spots of warming.
A hot spot because the heat can't go into outer space?
Well, it gets complicated, but it's exactly as you talk about. It's the patterns in which the things move. It has to do with concentrations of pollutants. So, for example, you get a lot of climate change. The reason I was in Mongolia was that's actually a place where there's so much climate change that the permafrost, the frozen soils are actually melting. And there's a strong record that's been documented by the Mongolian scientists. But you also have higher levels of sulfur pollution from the high sulfur coal that's going on in China, so that's been cooling here. And so those are sort of, it gets fairly complicated, and that's what we use the large supercomputers with the complex models to try and sort out.
Are we humans, are we damaging our living space?
We're having huge impacts on the environment.
We are.
Inevitably. It's a value judgment to determine whether we're damaging. But there's no doubt we're having huge impacts. You can see the hand of humans in almost any environmental record you look at.
Right on it. Absolutely. And I agree. And it's a value judgment. But the one thing in addition to it is it's directional, and so often that value judgment is not hard to make. In some cases, it's very hard to make because some people would value that change as positive. And let's say with climate change, that happens because they'll say, well, the people in some parts of Canada are going to produce more crops. So they might think of this, oh, this is a good thing. But then there are going to be parts of the Southwest where they're going to have much less rain, more drought, less crops. But in the aggregate, usually there's consensus.
This is fascinating. I'd like to, if I may, go back to another basic question, which I think people are going to wonder about because we're talking about this generally. We talk about, every day, we talk about high pressure and low pressure. Is high pressure more concentrated, or is it just high? We talked about a low pressure being lower and moving in. But are we talking in terms of greater pressure and lesser pressure, or actually high pressure and low pressure? When we talk on the nightly news about a high pressure front and a low pressure front.
High pressure areas are areas of sinking air. We start out basically with what you might call air mass theory and where air masses originate. Air masses that originate in northwestern Canada, for example, and all air masses tend to take on the characteristics over the area in which they form. So these up in northwest Canada, let's say they're very cold. Well, cold air is heavy, it's dense. And because it's heavy and dense, when one measures the pressure of it, you get high pressure.
So it's actually greater pressure.
So if you
it's
look,
dense and heavy.
right, and if you look and say, well, where is the high pressure, the pressure greatest, you would see that over northwest Canada and the Arctic region. And then in the winter, as that high pressure moves to the south and the temperature in the lower part of the atmosphere moderates, you see the pressure change. It may come down. So high pressures are areas of sinking air. When air sinks, it actually warms up. It may be very cold air. The warming process causes drying, and so then you typically get clear sky with high pressure. Low pressure, conversely, the air is coming together at the bottom, the air rises. As it rises, it cools. As it cools, the air condenses, and then you typically find clouds. So the whole reason we have weather is temperature difference. It's cold here and it's warm at the equator, and the Earth is constantly trying to reach equilibrium of temperature. So when you have hurricanes, they take warm air into the high latitudes, and when you have big high pressures and storms that are intense in the winter, they tend to pull cold air south toward the low latitudes to achieve temperature equilibrium.
So low pressure will move low weather to the
Well, low pressures typically will move from west to east across the country. So maybe it's a northwest to southeast, maybe it's a southwest to northeast kind of thing, maybe it's a south to north, but they will typically move like that. So if you have rain with low pressure in the middle of the country, it's the kind of thing where I'm looking at it and saying, all right, what are the steering currents looking like? Because they're going to steer it. And then I, say, okay, it looks like it'll be coming our way. And then you got to try to figure out all the little things.
Is there a conflict between high pressure sinking and low pressure just living there?
Well, the air, because of the rotation of the atmosphere on its axis, what's happening here is the air is actually moving out from high pressure and then into low pressure. And as it comes into low pressure, it curls into the middle and then rises, so to speak.
High pressure squeezes?
High pressure is turning clockwise. The air is moving clockwise in the northern hemisphere. Low pressure counterclockwise. And just think of high pressure as a big mountain and low pressure as a valley.
Right.
And you pour the water off of here and it runs down into the low.
During the summer months, during all months of the year, there's a high pressure center out over the Atlantic Ocean. During the summer months, that high becomes more intense, tends to move, to expand in size. That brings us our steady winds from the southwest, the warm, moist air, which is flowing around that high pressure center.
So clockwise and counterclockwise, and the difference in temperature causes a wind.
The difference in density causes the wind.
Causes the wind.
And the presence of the temperature difference between the equator and pole is what sets up the forces that initially cause the flow. It does get a little complicated. The three of us could easily offer a course, or you could go to Brown University or
you guys could offer the course. My brain cells lost all that stuff.
And then it's even the implications of it. So you have the physical processes, but just like with the dust story, it's what are the implications then of those processes, and that's where the human interactions come. Because when you change the surface of the Earth, as we have through human habitation, you change the interactions of those weather events, and then when you do that on a large scale, you change the climate even, which is the overarching framework in which that weather is occurring. So those temperature gradients start to change and patterns change. And that's where we are taking processes that were geologic, slow, the building up of the Midwestern lush soils that the farmers love and value. That took hundreds of thousands of years, and what we're doing is we're taking, it's like it's on speed. All of a sudden, everything is just the process. We've altered the systems at rates unprecedented. And it's really that rate of change, whether it be with climate change, whether it's with loss of the soils through blowing dust, that's really the challenge for human society.
Is the West in trouble now? People talk about the West going through 6 years of drought, maybe more, so that the farmlands, aren't what they used to be, but will they return? Or
those areas are arid. They've been arid for thousands of years. It is true that the changes that we make, the exploitation of the environment, probably makes those problems worse. It certainly brings us closer to a cutting edge or a very difficult situation.
How bad a thing is it if somebody has an aerosol spray and sprays maybe a fragrance or something in a house or something else?
In terms of health
Just
effects?
polluting the
In
air.
terms of, what is it doing
Air
to us?
pollution.
Well,
In our health.
aerosol sprays, there used to be concerns with aerosol sprays because of the propellant was free on gas, which was a marvelous invention, which turned out to have a bad effect on the ozone layer. That problem has largely been taken care of by regulation and improved chemical substances so those problems are gone. Anytime we release something into the atmosphere, we're making a change. I'm very much unconcerned about the things that we do. Well, we tend to do things to excess, even on an individual level. But I'm much more concerned with industrial processes and with large-scale activities that we carry out as humans than I am with, someone releasing some substance into the atmosphere in their home.
But it's a different kind of threat or issue, because there you're talking about to that individual. We're now learning very small particles move deep into the lungs. So it's no longer the
the
physical
health,
science
sure.
that I deal with. Now you're talking about human health and the degree to which adding these additional particles deep in your lungs. It's not a threat to the earth, but it is
But to your
maybe a
health,
threat
sure
to
it
your
is.
health. Sure.
Yes. Asthma is increasing tremendously.
Right, and we really don't
Cancer.
understand those relationships, but that's not my area of expertise.
But how about vehicles with the polluting the air? Certain vehicles. That's very dangerous.
There are many problems caused by the various forms of pollution that we put in. The air pollution from automobiles causes acid rain, causes ozone formation. The particulates that come from diesel vehicles, for example, have a bunch of negative effects. And the overuse of petroleum is a serious problem in and of itself. So there certainly are plenty of problems. Have I stopped using my car, and do I get
No.
around on a roller
We need it.
skate all the time? No, I don't.
We need it.
But the scale is
Today's
different.
world.
I actually do walk to work, and we do actually use mainly I drove here, but it is a scalar issue. And again, with a lot of those air pollutants, any single action is not a big problem, but in the aggregate, it can have big impacts. And places like China, as they've industrialized, they've realized it. So they've had to change their patterns of air pollution because the rate at which they were emitting sulfur dioxide, creating acid rain, the pollution in Beijing and other cities was just tremendous.
Okay, we're going to wind up today. First, we're going to dedicate this program to Hannah Hamburg, who is one of the guests we have today. Hannah is the daughter of Professor Steve Hamburg.
Come on over, Hannah.
Come on, Ham.
Come on over. Yeah, wave hi to
A
everyone.
delightful guest.
Come on over. Sit on my lap.
Welcome, Hannah.
That's our audience.
There you go. Yeah.
So I'd like to thank first to my left, Gary Lay, the most influential meteorologist in our state of Rhode Island in southeastern Massachusetts. And to
Art Lake too.
Art
I'm
Lake
an Art
too.
Lake fan, and
Oh.
my deceased dad was a John Giorgi fan.
Really? Now Channel 10
All together.
also hires Art Lake and John Giorgi.
Right.
This is Sandra Sanchez, our associate moderator.
Thank you for joining us.
Then we
all our
have
guests.
Hannah and Professor Steve Hamburg from Brown University, Environmental Science. And to all of our lefts is Professor John Merrill from the University of Rhode Island School of Oceanography. Please join us again next week.